Guys, this is because tomorrow is AS Paper 1 for Edexcel, and I'm presuming for other exam boards as well. So I'm going to take your questions if you've got any down below. But if you're watching right now, it's probably because you're not subscribed, or you are subscribed but you don't have notifications on. So make sure that you do hit that subscribe and notifications button. Okay, in this video though, I'm going to go through three key areas that are going to probably come up in tomorrow's AS exam. And they are ones that people find tricky, people make mistakes on, especially in this new syllabus. So I'm going to talk through those three. Those three areas are projectiles, moments, and working with perpendicular distances, importantly, and circuit problems. So if that sounds like you need to stick around. If you're watching the recorded version, then you need to stick around as well. And if you've got any questions, then do ask them in the comments. I'll try my best. I won't be doing any other videos tonight, but I'll try my best to, if I've got a video that will help you, I'll ping it out in the link as well. But in the description, I've put some playlists which will be really useful. I've got my practicals playlist because you're going to need to make sure that you've got your practical skills ready. I've got my mechanics playlist and I've got my DC electricity playlist. So I'm going to just jump in that in one moment. I'm going to go through, as I said, projectiles and moments and DC electricity. So that's circuit problems and how you can solve them tomorrow. Obviously, if you're doing GCSE, or you're doing the full A-level and you don't have an exam tomorrow, still stick around because this stuff is useful to you. And before I go anything, I just want to say something. Loads of people have asked me for AQA and CIE solutions, past paper solutions. And just yesterday, I was looking at a site called Scienceshorts. I don't know if you've come across this guy, Mr. Rees is his name. And he does amazing videos, and he is going through the CIE, the Cambridge International A-level exam board A-level thing. So I've linked up his page just down there in the description as well. Scienceshorts it's called, and he also goes through AQA. Now on top of that also, I have made some Edexcel AS question run-throughs which are on the A-level physics online site, so you can find them there. And also use my full A-level ones, but just skip the questions that are for the full A-level. Okay, I hope that all helps. That's like loads of things that you can find after watching this video, which I'm going to run through those three things. So without any further ado, let's start with, unless anyone's got any points, and I will stop just to go through some questions if you've got them between each one. So I'm going to do projectiles, then I'm going to do moments and perpendicular distances, then I'm going to do the Kirchhoff's laws bits for solving DC things. Now I've left my projectiles thing right over there, so don't worry about the lack of professionalism actually moving camera mid live stream. All right, okay. So here we go. This is my tips for solving projectiles. This is a typical one which people get wrong in the A-level and the AS. Okay, so here I've just drawn out some typical things, some typical kind of things. Firstly, you're going to recognize the shape of the parabola. Okay. Now, the key is not the data they give you, it's the data that they don't give you, right? So let's think about what they haven't given you. They haven't given you the speed at the top, okay? But you know, in the y dimension, that speed in the y dimension is going to be 0. So that's a bit of data they've not given you, but you know. And then also, you know the acceleration in the y dimension is 9.81 or minus 9.81. So what you need to do then is use those bits of unknown data to work out a time of flight. Now normally with all projectiles questions, whether it's a full projectile like this, where they're giving you a launch and they're probably going to ask you to work out a range, or they're giving you a range and they've asked you to work out a launch angle or launch speed or any of these things. It's all about working out that time of flight. And the way to do that is to use that unknown data and your suvat. And then you've just got to work in the two dimensions. So you work first in the y dimension, because you know more information in the y dimension than you do in the x. So you work in the y dimension, so you have to resolve this, the velocity, into the y dimension. Now there's a shortcut there, the angle alpha and the speed v, you swing that open, so the v, the velocity in the y dimension, is equivalent to v sine alpha, okay? So that's the velocity you use when you go into the suvat. And you use acceleration to be minus 9.81, and use a final speed of 0. And that will allow you to work out time, okay, from one of your equations of motion. Now remembering though, when you start working the x dimension, you know how long it's taken to go right to the top and down to the ground, because we say there's no acceleration in the x dimension. There's no acceleration in the x dimension. So the time is just twice that. It's whatever time it was to there, and then times it by 2, okay? So from that, because there's no acceleration in the x dimension, you can just work out the x by using good old speed distance over time, okay? So just to sum that up then, it's really much more simple than I think a lot of students make it, okay? It is because the information they don't give you, but you do know. So remember, you know the velocity in the y dimension at the top is 0, you know the acceleration is g, okay? You don't know the time, but that's your first stop to working out. And even if you're working backwards from a range, you still think about working out the time first. And then the acceleration in the x dimension is nothing. And that's normally a kind of follow-up question to that kind of thing. What have you assumed? You've assumed that air resistance is negligible. All right, that was projectiles. I hope that helps. I'll just have a quick look if there's anything in the comments that you've chatted, okay? Is the CGP textbook, not revision guide, good enough for making notes from? Yes, it is. Yeah, sometimes I get a bit annoyed with CGP. I looked in one today and I was expecting to find some detail which is in some exam question kind of mark schemes, and it wasn't there in the CGP. So CGP is not always great. Everybody makes mistakes, but they're as good as I think any other kind of textbook that's out there. I did, if you look back at my last live feed, I think it was maybe last but one, I've gone through all electromagnetism for GCSE. So my suggestion would be go and check that out, if that's all right with you, okay? All right, next one, moments. Now moments are such an easy concept, okay? Remember what a moment is? A force times a distance. You need to know that for GCSE as well, okay? But people always get stuck because they get this kind of complicated diagram. Now this, I've just made this up here, okay? But I can remember one is about kind of, past paper one is about this, what do you call it, basketball net, which is being pushed over. And then also there's one about like a kind of crushing a skull, and about the kind of turning forces in crushing some food. Okay, so what I've done is I've tried to make quite a complicated looking moments question. Now here's my kind of tip, right? Now before you calculate anything, firstly identify which of the forces are acting to turn clockwise and which are anti-clockwise. So F2 and F3 are going to act to turn this, that's the pivot in the middle there, in the clockwise direction. Okay, have I got that right? Well, that's the anti-clockwise actually, isn't it? But okay, the anti-clockwise direction. Now F1 and F4 are going to turn it in the clockwise direction. Okay, so that's our start point. We've identified those. Now remember, the distances we're given, P, Q and R in this case, are not the distances we need to use in our calculation. We need to use the perpendicular distance. So we need to do our trig before we do anything, okay? So always do trig before you do any other things. So basically convert R into the perpendicular distance to the force, which is this distance along this arm here. So again, we're closing the angle, so that becomes R cos alpha, R cos A, okay? Then what was the other one? It was F3, and I've been even a bit tricky there because I've done that and you've been told in the question somewhere that it's halfway along this one. So the distance is Q over 2, but we need to use the perpendicular distance again. So we're looking at this one here. Again, we're closing the angle, so it's going to be F3, the force, times the perpendicular distance, which is Q over 2 cos B, okay? Then we've got, that way we've got our, it's actually the anti-clockwise. We see the top line there, F2 R cos A, and FQ over 2 cos B is the top line there, and that is the sum of the anti-clockwise moments. If the thing is balanced, then that will equal the sum of the clockwise moments. So then we write the same thing, we write a formula for the other side, for the other way, okay? But again, we're just looking to make sure that we always turn our distances into perpendicular distances. So here, P becomes P cos C. Okay, so this moment caused by this thing is F1 P cos C. And the other direction of this one, well, this is the only one here where Q is actually perpendicular. So this is just FQ. Okay, so that is why people struggle with their moments questions. I've done clockwise and anti-clockwise is the wrong way around here, okay, but I'm not too bothered by that. The point is, the principle of moments says that they're all balanced. Okay, and it's normally going to be about either a balance of those forces and working out one of those unknowns. So there'd be one of those, it might be F4, might be Q, okay? It'd be one of those that wouldn't be given. You just have to make You'd have to plug in all the numbers that you know, and you'd have to make this one equal to this one and work out your one unknown. So that's just a case of simplify and then rearrange to find out your answer like anything else. I think a lot of students struggle with that idea that something like p cos c is just a number that can be moved around as a little group. It's just one number, one piece of algebra, all the way around in your algebra, like any other piece of algebra. Now I hope that helps. Okay, all of this is listed out in the description, and if you think about these things, I've got the playlists for the mechanics and the DC electricity, which is coming up in your AS exam tomorrow, linked up in the description as well. Let's see if there's anything that isn't just chat about Wenger. It's pretty much all Wenger stuff. Okay, but Lane has asked, why is it when we increase the launch angle in a projectile up to 45 degrees, the range increases, but it starts decreasing from 45 to 90 degrees. So it's about the respective change in time of flight versus the horizontal component. So once we've worked out our total time of flight, okay, which is going to be a maximum if we're at 90, okay, then we use the horizontal component of the velocity to work out the distance, okay, just with distance is speed times time. But if you think about this, Lane, then if it was at 90 degrees, it'd be longest time in the air, but it wouldn't have a horizontal component, so the range would be 0. So 45 is kind of the best balance, 45 between spending a long time in the air and still having a large enough horizontal component of velocity. All right, I hope that makes sense. Good question. Anything else just now, or shall we move on to circuit problems? Okay, now, yeah, the one thing, yeah, all right, Ben, yeah, the electricity section is coming up, yeah, absolutely. My pleasure, Lane. What was I? One thing that I always think about is that all of this stuff is just a toolbox to, solving the problems. So remember this, every single problem is different in a physics exam. We cannot practice, we will not be given the same problems that came up last year. We will not be given the same problems from any past paper. It is just the tools to solve the problems that's the same, okay? So when you're revising, think about filling your head with those tools, and then what you can do from then is solve the problem, okay? So think very carefully about the problem that you're solving. And all of these things can be little bits within much larger problems. So you need to take your time and really think about the bits you can solve. If you can solve little pieces of the puzzle, those answers will be other components in solving the next step. So a lot of the time with DC electricity, it is actually the little bits of solving the problems that leads you to solve the bigger problems. All right. So what I want you to do is think about these circuits and just memorize these 3 laws. They are Kirchhoff 1 and Kirchhoff 2, and Ohm's law. Okay, good old Ohm's law. Now, Kirchhoff 1 is actually the middle line, and it states that currents into a point equal the sum of the currents out of a point. Okay, now that is borne out in this algebra here for a series circuit where in fact there's only one input and one output for every single point, so all of the currents are equal. This one is parallel circuits where the current splits into the currents in the branches. Okay, so that's the algebra that you just remember for Kirchhoff's law, Kirchhoff's current laws, or Kirchhoff's first law. Kirchhoff's second law states that the sum of the rises and falls of potential is equal in any series loop, in any loop. So that follows this one. This is like the supplied voltage, if you like, and these are the voltage users in the circuit. But you don't need to really understand it in that type of terms. Just use and remember the algebra. V1 equals V2 plus V3 plus V4. Then your parallel circuits. Okay, now in parallel circuits, all the branches have a direct connection back to the actual battery. So this is this one. All the voltages are equal. Every branch of the circuit has the same voltage as the supply voltage. Then there's Ohm's law, okay? V equals IR obviously can be rearranged. If you know V or I, you can work out R. If you know R and I, you can work out V. And if you know V and R, you can work out I, right? You can do that at any place in the circuit as long as you use the correct V and I from any of these things. And what follows from that is the rule about series resistors. So the total resistance in series is just the sum of the resistances. And there's the parallel resistors. Now in GCSE, you can kind of just remember that if you add more resistances, you reduce the total resistance. But at A-level, you need to remember that you sum the reciprocals, and that gives you the reciprocal of the total. Okay, So in practice then, let's think about what that's going to look like. They might give you a series circuit, okay? And they're going to tell you some, but not all of this information. And they might be asking you to work out something about this resistor or something about the power supply. Okay, now you need to, if you're told the current here, for example, you need to know that's the same current through the power supply. If you're told the voltage here and the voltage here, then you need to know that this V3 is just V1 take away V2, okay, if you were asked about this particular resistor. So the point I'm trying to make, I hope that makes it clear, is before you can sort of answer a certain question, you have to figure out, using the information you have been given, you have to figure out the stuff you haven't been given, the stuff you need to solve that particular problem. In a parallel circuit, well, the same goes, okay? But this time, maybe you've been given one of these currents and the other current, or maybe you've been given one of these currents and a resistance of one of these resistors. So you need to use that, and knowing that the voltage is the same through that one as the voltage of the power supply, to work out the current through that one. So you've been given that current and you've worked out that current, then you can work out that current and use that current to do something with this resistor. So circuit problems is all about knowing your toolbox, and that's your toolbox. I hope that's not kind of news to you. In the DC electricity playlist, I go through this and the derivation of the R terms there, okay? And well, I know you're going to be able to use Ohm's law, but do you know that in a circuit, you can always apply Ohm's law in a branch or at a certain point around a series circuit, so on and so forth. Right, I hope that's helpful, you know, like really do think about that. The stuff you learn, the stuff you revise tonight, should just be like a toolbox, right? Okay, it should just be like a toolbox to solve the problems. Do your best at applying the knowledge and understanding you have to solve the problems in front of you, and you do absolutely fine. Okay, there's a couple more things just to say, and then I'll say goodbye, and I'll see if there's any questions. Any questions, be quick then, please, because I'm going to wrap this up pretty soon. In the links in the description, there's a playlist for the exam for the full A-level, which has these topics in. And within that, if you click on the playlist, you'll find some moments questions, you'll find some DC electricity questions, right? And then next one, don't forget to go over the experimental stuff as well. And I went through the experimental stuff in the previous live feed, so go back over the live feeds. Skip through, you know, be picky now, okay? Don't spend all night panicking. Don't spend all night working really hard on some really, really tricky questions. Spend tonight with some kind of more chilled revision, some just kind of gentle stuff, kind of remind yourself of some of those stuff that you know, but you just need to know, be ready to go in that exam. All right, last few questions then, dudes, and then I'm going. So, loads of people having a go at Edexcel. Yeah, electricity is paper one for Edexcel, yeah. It was in physics too. I don't know what it is in for AQA. Have you got any questions with anything, any particular parts of AQA? I mean, I can't go through it in that kind of detail, but I'll give you some hints. Yeah, it's old spec paper 2 and new spec paper 1. I do my research, don't get stuff wrong. Well, I do get stuff wrong, but you know what I mean. All right, how does Newton's third law support conservation of momentum? Well, because the forces are equal and opposite reaction, and a force is defined as a rate of change in momentum. So if the forces are the same, then the momentum in opposite directions must be conserved. It's not necessarily the same in opposite direction, but it must be the same as it was before. I hope that makes sense. I always say Newton's third law is actions of equal and opposite reactions with all of those kind of consequences, same line of action, same time of action, same type of force, different bodies, equal magnitude but opposite direction. But then I say a consequence of that is conservation of momentum. But you can kind of treat them separately because they're used to solve different problems. Derive the critical equation formula. I have no idea, Ayub, what you're on about there, buddy. Critical equation formula. Is it something? Oh, I know what you're talking about. Critical mass one. Do you know? I haven't done that in my syllabus, right? So I know the one you're talking about. I'll have a little look over it, bud. I'll see if I can do it. Is it for tomorrow, Ayub? Because I probably won't be able to get it done if it's for tomorrow. I don't know if is it AQA? I think it's AQA, isn't it? I don't know whether either the best place to look would be A-level physics online or Scienceshorts. They probably have one. Can you do some required practicals for GCSEs? Yeah, I have done Cryptic God 11. I've done quite a few actually. If you kind of look back through them, but I tell you what, the best place for the required practicals for GCSEs are actually Malmesbury Science. okay, Malmesbury Science Department. They've done some wonderful videos for core practicals. There's loads of good ones there. If there's any particular one that you need, then do let me know. If you look, for the required practicals for GCSEs, if you look back over the my AQA playlist, then there'll be stuff in there. And also there's full AQA exam papers, there'll be stuff in there on them as well. Just say about required practicals. No, I've gone, oh no, yeah, my name's Kit. Yeah, this is Gary the Gorilla. This doesn't matter. Daniel, how do you draw a tangent to a graph and calculate a gradient? Pretty sure I've done that in a previous one as well. It's a really important thing for the new GCSEs. So what I do, say this is my curve, okay, and you need to get yourself a ruler of. Just give me a sec for the mic. So this would be my curve, right? And then you're looking to put your ruler on, okay, at the point. So if I want the tangent, it's tricky to do one-handed. If I want the tangent at this point here, let's say, okay, then I'm going to put my ruler on, and I need to make the gap here equal to the gap there. Can you see how that's not going to be an accurate tangent to that? Because the gap just sort of 3 inches this way is much smaller than the gap 3 inches that way. So I need to place this ruler so the gap 3 inches either side is about equal. I think I still need slightly bit like that. And then you do the tangent. Okay? Happy? That makes sense? Quite impressed with that for a handheld tangent, actually. But then you do dy by dx on that, so you do the rise over the run on that one. Okay, and that's your gradient. Let me know if that helps. Thumbs up if that helps, okay? Last ones then. 4th of June. Okay, I'll have a look, Ayub, okay, and I'll see what I can do with the critical density one. It's very interesting, isn't it? Newton's law questions, how when a coin is flicked towards a stack of coins, the bottom coin moves. Because there's no resultant force on the ones above it, right? Okay, so if the coin is hitting just the bottom one, then there's a resultant force for that one in that direction, horizontally. But there's no horizontal resultant force on the ones above it, so the stack just falls. That makes sense? So that's Newton 1 and or 2, if you like, which is resultant force, therefore acceleration. So there's no resultant force in the vertical direction. There's only just fall straight down because its weight is a resultant force downwards. Does that make sense? So Newton's laws, it's about learning them and then just learning to apply them. Okay, so the first two are about resultant forces and acceleration, and the second one, the last one, the third one, is about actions having equal and opposite reactions. So it's just a matter of basically think, right, is there a resultant force? Is it about acceleration? Okay, then you're thinking applying Newton 1 and Newton 2. Or is it just about an action-reaction pair, okay, then you're applying Newton 3. And another trick to that is thinking about, are they on different bodies or on the same body? Pairs of forces on the same body are Newton's first or second law pairs. Pairs of forces on different bodies are Newton's third law pairs. Newton's third law, they must be the same type, same time, same magnitude, but opposite direction. Pairs of forces on the first and second law don't have to conform to any of those things. And it's about resultant forces, and I hope you get what a resultant force is, like an overall net force, yeah? Hope that helps, bud. How can I at least pass? I haven't studied at all. Well, you made a mistake in not studying. How can you at least pass? Well, focus on the kind of simple stuff. Focus on the kind of memory work, okay, just now. Focus on the kind of set explains, make sure that you've got your definitions. And focus probably on the maths, because if you've picked A-level physics, I hope you can kind of do a fair bit of maths, okay? Focus on making sure you know exactly what each part of the formula sheet is used. You see my formula sheet now on the wall is covered in lots of annotation, because I'm making sure that my team, my squad, they know exactly what to use each formula for. So right now, get yourself a formula sheet, okay? Go through my past paper questions or anything like that, or go through your textbook and make sure you know exactly what and when to use each one of those formula, and then you'll probably pass, okay? Please, yeah. All right, I'll try my best. Yeah, A-level practicals, again, I've got quite a few A-level practicals, not all of them, but A-level physics online has got loads of good detail about those. Okay, I think that's me. Guys, I'll be thinking of you tomorrow, yeah? You'll do absolutely fine if you've been working hard, and I'm sure you have been. And I know, Mohammed, that you're talking about you haven't, but I'm absolutely sure you've been doing your bit over the time, all right, bud? Okay, thank you all for watching. Let me know if that's useful. Let me know things for significant figures. Is that significant figures? Is that for like practicals? Yeah, is that for practicals? I imagine it is. So just remember, we want to read. We want to record all our data and practicals to the same number of significant figures, right? And you will only be penalised if your answer doesn't round to, this is in any question, round to the answer given in the mark scheme to that number of significant figures, right? So if they tell you 2.0 meters per second, okay, that means they're expecting an answer that rounds to their answer to two significant figures. Okay, so give your answer to two significant figures. My tip that I always did when I was your age doing my A-levels was I just wrote down the digits on my calculator, or at least a few extra sig figs, and then I did a bit of rounding. And you can never really make that mistake, because we'll check the longer one, and then we'll go ahead and check the other one. But it's good skills to work to that number of significant figures, and make sure you don't round. At least keep a few more significant figures, like 5 or 6 or something, throughout your working, or do all your algebra and put your numbers in last, so you're not losing any precision of your data throughout your calculation. So your final answer isn't warped by a premature approximation that you made earlier. So you rounded to two significant figures too early, and that's meaning your answer comes out as not correct to that number of significant figures. Hope that makes sense. All right, cheers guys, see you later.